Okay, this is to solve example number 8 in section 10.4. The example says, find the area of the region that lies inside the circle r equals 2 cosine theta, which is this circle over here, and between the two vertical lines, theta equals pi over 2, which is this line over here, the y-axis, and the vertical line r equals 3 over 2 secant theta, which is this vertical line over here. Remember that we said in the class, to make sure that this line is a vertical line, we can convert the polar equation into a Cartesian one. So r equals 3 over 2 secant theta. To convert this polar curve into Cartesian curve, we can multiply both sides by cosine theta. So it becomes r cosine theta equals 3 over 2. And remember that r cosine theta is nothing but x. So this is an equation of vertical line, x equals 3 over 2, right? Now, to find the desired area that we want to find is the area that is inside the circle, okay? We want to find the area inside the circle, but between those two vertical lines, okay? So inside the circle and between those two vertical lines, it means this red shaded area is the area that we want to calculate. Okay, another thing, note over here that this area, this shaded area, is symmetric about the polar axis. So it means that it is enough to calculate this area above the polar axis, and then you just multiply it by 2 to find the whole area. So our task is just to calculate this area above the x-axis. If we multiply it by 2, we're gonna have the total shaded area inside the circle and between those two vertical lines. Okay, now let us find those two intersection points. Look over here. Those two intersection points are the intersection of the circle and this vertical line. Okay, so the intersection between the circle and this vertical line. So to find those intersection points, we equate the equation of the circle and the equation of the vertical line. So 2 cosine theta equals 3 over 2 secant theta, which is the equation of this vertical line. Now solve this equation for theta. If we multiply both sides by cosine, what do we get? We get 2 cosine squared equals 3 over 4. Now we can divide both sides by 2. So cosine squared equals 3 over 4. And then if we solve for cosine theta, it becomes square root of 3 over 2, which means that theta equals plus or minus pi over 6. So it means that this line over here is theta equals minus pi over 6, and this line over here, theta equals pi over 6. Okay, so this line is theta equals pi over 6. Now, remember that we are interested in the shaded area above the polar axis. So this area, okay, this area. So we are interested now in the blue area above the x-axis. And also you can see over here that we can divide this area into two parts. Let me call this one A1 and this one A2. Okay, so this is A1, this is A2. We can find A1 and then we can find A2. We add them to have the shaded area above the polar axis. Now, the area equals, okay, now the whole shaded area equals twice the area in the, twice the area above the x-axis. Okay, so the whole area, the total area equals total area equals twice the area above the x-axis. Now what is the area above the x-axis? The area above the x-axis is A1 plus A2. So A equals. Now what is A1? What is the shaded area? Note that this shaded area is the area under which curve? It is the area under the vertical line. Okay, so we just use the formula. The area under the polar curve equals half r squared, alpha to beta d theta. Okay. Now, so using this formula, we can calculate A1. A1, it is just the area under the vertical line 3/2 secant theta. If you calculate this from theta equals 0 to theta equals pi/6, if you calculate this area from theta equals 0 to theta equals pi/6, you're going to calculate A1, which is the area under this polar curve 3/2 secant theta. Okay, since if you have, for example, the spin, if you go from 0 to pi/6, then you're going to sweep out this area A1. Okay, so it is 1/2 integration from 0 to pi/6 r squared, but r is 3/2 secant theta, so 9/4 secant squared theta d theta. Plus, now what is A2? A2 is 1/2 integration. Now, A2 is the area enclosed by the circle and pi/6 Okay, so theta goes from pi/6 to pi/2. If theta goes from pi/6 to pi/2, then you're gonna sweep out this area under the circle, which is A2. So theta goes from pi/6 into pi/2, and the area under the circle r equals 2 cosine squared. So we're gonna have r squared, which means that 4 cosine squared theta d theta. Okay. Again, the whole area, the whole red shaded area equals twice A1 plus A2. Okay, why twice? Because we can just calculate the area above the x-axis and then multiply it by 2 to get the whole shaded area. Now, what is A1? A1 is the area, this is A1, okay? It is the area under this polar curve, which is the vertical line, r equals 3/2 secant theta, between theta equals 0 and theta equals pi/6. A2 is the area enclosed by the circle, okay, and the line pi/6, the line pi/2, right? So this will be the integral to find the area. Now I guess you can continue, it's easy. Okay, I have two quick remarks. The first one, note that over here cosine squared theta equals 3/4. Note that the intersection points, one intersection point is in the first quadrant and the other intersection point is in the fourth quadrant. So in those two quadrants, cosine theta is positive. Okay, cosine theta is positive in the first and fourth quadrant. The other remark, A1. We said that A1 is the area under the polar curve r equals 3/2 secant theta from 0 to pi/6. Okay, one might ask, why it is the area under the vertical line? Why it is not the area under the circle? Okay, from 0 to pi/6. Look over here. If you calculate the area under the circle from 0 to pi/6, you're gonna calculate all this area. Do you agree? You're gonna calculate all this area. But we are not interested in this region because it is outside the vertical line. It is to the right of the vertical line. We are interested only in this part. Okay, so if you calculate the area under the circle from theta equals 0 to theta equals pi/6, you're going to calculate the whole area here. The whole area here, which is not the desired one, because A1 is just this area. This area is not included.